As another example, let's look at the rule constructive dilemma. Let me bring one up here. And by form, this rule looks like this. P or Q, a little bit lowercase, P or Q, gotta love word. If P, then R, and if Q, then S. So, if R, then, R or S. Now again, P, Q, R, S are all just placeholders for either atomic statements or larger formulas. But whenever you have a statement that is essentially a disjunction, and whatever is satisfying the P in this disjunction is the antecedent of a conditional that leads to R, whatever is Q in this disjunction is the antecedent that leads to S, then you can say if R then S. Let's look at an example in the homework. Okay, here's one right here, number 6. I think we're going to need to use that. I'm going to copy it and paste it into what we were working on. Okay, here's the problem that we're given, or the argument that we're given. We're going to need to prove that it's valid. So let's start here with line 6. What's the next move we can make? Well, it looks like we can use constructive dilemma here, because look, we've got a disjunction. And handily enough, they put it all right here together. These could have been in any order, and they could have been spread out throughout the proof. But what satisfies the P of this disjunction is now the antecedent of a conditional that leads to Z. The Q of this disjunction, which is not G, again, not just G by itself, but the entire thing, tilde G, is now down here, and it's the antecedent that leads to this. So we can say Z or not R. We didn't have to spread it out that much. It would follow from lines 1, 2, and 3, and the rule of constructive dilemma. It's kind of nice to note how many premises are needed when you're doing any particular rule. For instance, modus ponens will take 2 premises. Here, constructive dilemma takes 3. That way, when you're working on the proof, if you use a rule, say modus ponens, and you've only added 1 number, then you're missing something. Here, if we had only put down 2 numbers and used the rule constructive dilemma, that would have also been a problem. Let's plug this into the proof checker on the Power of Logic website just to make sure it likes the way we did everything. Let's go in here to number 6. Let's see if this would have been a fine next line. Boom, it likes it. So be sure to utilize that as a tool to check your work as you go. Of course, this is only the beginning of this proof. If you want to do the rest of it, feel free to do so. Actually, please do so.